I will let you hold on to these until, so you can study from them, correct your mistakes. Some of you have a lot of correction to do, some of you do not. It really was kind of, there were a lot of A's and high B's, and then there were another group that was low. It was kind of an inverted score, kind of a U-shaped if you were to plot it instead of the bell shape. But that's pretty typical for this quiz, because a lot of people on 1, 2, 3, and 4 forgot which quadrant you were working in and dropped negative signs. And if you drop the negative sign, the answer is just wrong, is what it comes down to. Or you're mixing up your x, y, r's. You were forgetting which function was reciprocal of which and how it sets up. By the way, I have a present up here for, I believe, Jenna. Yes. Congratulations, you have a present waiting for you on Monday morning. So, watch your quadrant, watch your signs. That's honestly about half the people who did poorly on this could have raised your grade 10 to 20% just by watching your signs a little better and watching your quadrant. I mean, really, that it was that big of a disaster if you forgot if you just put everything as positive. It really is like a 20 to 25% knock on this score. So be aware of that. You really have to watch that. So, like number 1, we were in quadrant 4, cosine of theta was 3/5. So cosine theta is 3/5, and we're in quadrant 4. And a lot of people even sketched it correctly. Some people didn't sketch it and just went with straight definitions, which is fine. But again, cosine is x over r, so y is going to be negative 4, not positive 4, because we're below the axis. Quadrant 4, the only values that are positive in quadrant 4 are cosine. I mean, we can go back to our all students take calculus. Only cosine and its reciprocal are the only positive ones in quadrant 4. So cosine and secant are the only ones that will be positive. All the other functions are going to have negative value because they're going to involve that y, which is negative 4. So again, if you forgot your quadrant, if you lost track of that, and you just went and did x, y, r, and you did y as positive 4, and did that throughout, you got all those problems wrong. You got all those solutions wrong. And you need to correct that. But I think that's a fairly simple correction to make. I think that's something you can do between now and tomorrow when the chapter test is, right? We can learn to not do that again. So, again, sine theta is y over r, negative 4/5. Cosine of theta we were given, but I'll just do this anyway, is 3/5. Tangent of theta is y over x, not x over y. I get some people who flip those. Tangent has the y on top. It's like slope, which would be negative 4/3. Then we start doing reciprocals. The reciprocal of sine is cosecant. That's r over y, which would be negative 5/4, or 5 over negative 4 if you prefer. Secant of theta is r over x for the reciprocal of cosine, which would be 5/3. And cotangent of theta is x over y, which is negative 3/4. And again, I really don't have these memorized. Honestly, after all these years of teaching pre-calc and trig and all these other things, I don't have those ratios memorized for secant, cosecant, and cotangent because I don't need to. I know what they're reciprocal. I know that cosecant's reciprocal of sine. Since I have sine memorized, I can very quickly figure out what cosecant is if I have to. I mean, sine I can rattle off my head, y over r. Cosecant I would have to think about, and I'd have to think about sine and then flip it. So, again, I just remember which is paired with which. That cosecant goes with sine, that cosine goes with secant, tangent obviously goes with cotangent. So if one right, I can easily get the other one. So again, the biggest mistake here was dropping negative signs. The other mistake I saw, which was a little bit different, is I saw some people, and this is not uncommon, they got, especially once you start using the calculators, like we did at the end of the week, they got like secant, or, no, it's not use secant, let's use cosine. Cosine of theta was 3/5. And then what they did is they went in their calculator and took the cosine of 3/5. They put that in their calculator and got a decimal value. Well, no. 3/5 is not theta. We take the cosine of an angle. This is the value of the ratio for that angle. 3/5 is not the angle. I don't take the cosine of the ratio. That's not something we do, or the sine, or the tangent, for that matter. The ratio is the value for that. If I wanted to find the measure of the angle, I could do the cosine inverse of the ratio to find the angle. That's nothing we're required to do here, though. The other mistake I saw was a couple people did this. They did cosine inverse of it to find the angle, and then they just used their calculator once they found that angle to decimally approximate the sine, cosine, and all the other values for that angle. That's not what we're looking for here. These are ratio values, these are the x, y, r's. And it does say find the exact value. When it says exact value for something, that means don't punch it in your calculator and give me a decimal approximation. That means actually find the exact value as a ratio or a radical or whatever it takes. All right, I've got far too many people who that was their mistake, is they decimalized things and didn't give me exact values. They gave me things like 0.2635 ... That's not an exact value. So watch that. For number 2, we're in quadrant 1, so most people got this one right because there are no negatives to mess up. Secant is 25/7. Now that threw a few people off because they didn't know what the ratio for secant was. But if secant is 25/7, I already know that cosine theta, freebie, is 7/25. It's a reciprocal, right? So now, because I don't have this one memorized, I do have this one memorized. That's x over r. So I know x is 7, r is 25, so x squared plus y squared equals r squared. The Pythagorean triple here, I get y equals 24, and it's going to be positive because we're in quadrant 1. Everything's positive in quadrant 1. It's the happy place. So once I know y is 24, then I get sine theta is 24/25, and it's reciprocal. Cosecant theta is 25/24. Tan theta is y over x. I know y is 24, x is 7, so that's 24/7. And cotangent theta would be the reciprocal, 7/24. That's it without a picture. And all I did was use that Pythagorean identity to do it without a picture, which is fine. Especially since we're in quadrant 1 and we don't have to worry about negative signs. Number 3, a little trickier, just because it says cotangent theta equals root 3 over 3. But that's fine. If that's true, then tangent theta is 3 over root 3, which I would rationalize because we always put in simplest terms. That gives me 3 root 3 over 3, or the square root of 3, which, for the purpose of my ratio, I would put over 1. So that's y over x. But we're in quadrant 3, which means x and y are both negative, aren't they? X and y are both negative in quadrant 3. So, if I draw my picture, I get y is negative root 3, x is 1, that winds up being 2. It's a 30, 60, 90 triangle. It's identity. Okay? So then I can very quickly, I guess that's negative 2. Sine theta is y over r, root 3 over negative root 3 over 2. Cosine theta is x over r, negative 1/2. Cosecant theta, the reciprocal of that is negative 2 over root 3, which we know how to rationalize because that's identity. Negative 2 root 3 over 3. And secant theta is the reciprocal of that, which would be negative 2. We've got all the angles figured out. Some of you really tortured the radicals there when you were simplifying the radicals. Some of you really, yeah, tortured would be a good word. I mean, it was kind of brutal. But watch your work with the radicals. Always try to simplify. And when you saw that cotangent root 3 over 3, that should have been oh yeah, that's one of my identity values. Root 3 over 3 is an identity value for tangent and cotangent. For tangent and cotangent, the pattern is negative root 3, negative 1, negative root 3 over 3, 0, root 3 over 3, 1, root 3. Those are my identity values for my cosine, or my tangent and cotangent angles. So makes it kind of nice. The last one, all you really need to do is reduce that. 10 over 6 could easily reduce to 5 over 3. And once you did, we're in quadrant 2. Sine and cosecant have to be positive. Everything else is negative. So it went 3/5, negative 4/5, negative 3/4, negative 4/3, and negative 5/4. So, and honestly, those first 4 questions, that was 40% of your points right there. So if you mess that up badly, that really did mess up your score quite a bit. Number 5, again, very similar. It says draw a picture, find the exact value when the point negative 912 is on the terminal side of the angle. Just phrasing it a different way, but negative 912 would be up here. We always come down to the axis this way. All right, so that means this is negative 9, this is 12. What's this third side going to be? 15. We do Pythagorean theorem. And all that's is for sine and cosine. So sine theta is simply y over r, which reduces, 3 goes into both of those, so that's 4/5. Cosine theta is negative 9 over 15, or negative 3/5. That's all there was to it. But I had several people who put it in the wrong quadrant. They put it down here instead of up here. Okay? Quadrants go around 1, 2, 3, 4, counterclockwise, the same way as our rotation. Which quadrant is, I was surprised that people struggled with this as much as they did. A lot of people lost points here. And again, it's not that hard. If you remember, all students take calculus. All students take calculus. Okay? All functions are positive in this quadrant. Okay? So this means sine and cosecant, because they go together, are positive in this quadrant. This means tangent and cotangent, because they go together. And here it's cosine and secant, of course, because they go together. So, number one, sine is positive and cosine is negative. Well, sine is positive here, and sine is positive here. So there's sine and sine positive. Cosine negative, cosine is negative here and here. Which quadrant is true for both of them? Quadrant 2. It's the only solution. 7, tangent is positive and secant is negative. Tangent is positive here and here. Secant is negative here and here. There's my quadrant that has, see like a smiley face, it's got 2 dots. Just starting a smiley face, that's all. So there's my quadrant. Quadrant 3. Next one, cotangent is negative and tangent is negative. Well, cotangent and tangent always have the same sign, don't they? Cotangent is negative in these 2 quadrants, tangent is negative in these 2 quadrants. We have 2 solutions. Quadrant 2 and quadrant 4. And it does say which quadrant or quadrants can that happen. And finally, last one, cosine theta equals secant theta. That can only happen if cosine theta equals 1. So that's not in any quadrant. That's on the axis. And I did warn you about that one. We did one like that in class. What if I said cosine theta equals 1? Where does cosine theta equal 1? Well, on the axis. Should be the x-axis. But if you just said axis, I pretty much gave it to you. People said y-axis. I didn't mark you down for that. It's the x-axis. Okay? Because cosine and secant are reciprocals. The only time they can have the same value is if they're 1. Right? Anything else, they will never have the same value. The only number that's only reciprocal is 1. So that's not in any quadrant. Number 10, the exact values of the 6 trigonometric functions. Again, a lot of people messing up here because they use decimals. Decimals are not exact values. We can use decimals to help us find our exact values or to indicate what our exact values are. All right? I mean, if you put this in your calculator, and again, just a few hints for our exact values for identity functions. Obviously, 0 equals 0. 0.5 is the same as 1/2. 0.707 ... that's the square root of 2 over 2. 0.866, etc., is the root 3 over 2. And 1 equals 1. Those are my identity values for sine and cosine. And it helps to be able to recognize those because your calculator can help you with this. The other thing you have to remember is that where is 7 pi over 6? That is in quadrant 3. So we're going to get a lot of negative values here. Now, the best way to do this is to draw my angle in 7 pi over 6. There it is. Which means this angle is just pi over 6, which is the same as 30 degrees. So this is my 1, this is my root 3, and there's my 2. There's my 30, 60, 90 triangle. Because it's identity, it's going to give me a 30, 60, 90, or 45, 45, 90. Here at pi over 6 is 30 degrees. That's our conversion. And there's our triangle. So that's another way of doing it, is by drawing the triangle out there. And remember, we have negatives, and then it's just using your x, y, r's again. The final way to do it would have been to think through my chart and say, okay, if I think through my chart, sine goes up, there's my pattern for sine right here, and it would go back down, root 3 over 2, root 2 over 2, 1/2, negative 1/2, and remember my angles go 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, 7 pi over 6. Aha, there's my value of sine using my pattern. So 3 different ways we could figure this out. I could remember my pattern for sine and just work my way down and then build off of that. I could draw a picture identifying the angle and knowing my 30, 60, 90 triangle. I could use my calculator to find the decimal values and just change those decimal values into their counterparts of radical values. 3 different ways of getting that across. Not one of which is just punch in your calculator and write what decimal value you get. And again, quadrant awareness, very important. We had to know which quadrant we're in. Number 11 and 12, no one should have gotten any points off here. It's just punching a number in your calculator. Surprisingly, some people did. They forgot to convert between modes in their calculators. Second, it's the secant of 3 pi over 7. Okay? That's not the same as cosine of 7 over 3 pi. You find the cosine of 3 pi over 7 and do the reciprocal of that to find the secant. So when it says secant 3 pi over 7, I'm going to calculate my calculator cosine of 3 pi over 7. That's 1 over the cosine of 3 pi over 7. That's what I'm going to calculate. Not the cosine of 7 over 3 pi. That does not work. And not the reciprocal of the angle, the reciprocal of the cosine. Secant is the reciprocal of the cosine, not the reciprocal of the angle. So I think some people did this, take the reciprocal of the angle instead of the reciprocal of the cosine. Tangent negative 268, that one was fairly obvious. I mean, that literally was pushing buttons on your calculator. Yes?
Question on number 11.
Yes.
How do you set it up in your calculator? Because I put cosine of 1 over, then I put parentheses.
No, not cosine of 1 over. It's 1 over cosine.
Okay.
Yeah, you did this. You did this instead of 1 over cosine. So 1 divided by, and then parentheses, cosine 3 pi over 7. So it's the reciprocal of cosine, not the reciprocal of the angle. Reciprocal of the function. Find the angle between 0 and 360 to the nearest tenth of a degree where cosine is negative and sine is positive. So again, we had cosine is negative. So that means we're in these 2 quadrants. It's the x value. Sine is positive, so that must mean we're in quadrant 2. Here's our happy face. Happy faces are important. They help us find things. They make us happy. All right? So I know I'm in quadrant 2. That's important to identify which quadrant you're in. Quadrant awareness is huge. The sine is 0.7521. So in my calculator, I do the sine inverse of 0.7521 to get the angle, because we use the inverse function when we're looking for the angle measurement. When I do that, I get 48.8 degrees, which is marvelous and fabulous, and that is the sine inverse of 0.7521, which is this angle right here. However, that angle is not in quadrant 2 where I need to be. I need to be in quadrant 2. But because of symmetry, I can very quickly figure out that this angle is 180 minus 48.8 degrees. or 131.2 degrees. So by being aware of the quadrant, I was able to find the correct angle. A lot of people gave me 48.8, which is fine. The other thing I saw a lot of, though, is I saw a lot of people take the sine of 0.7521. I saw that a lot, and they said like 1 degree or something like that. If I take sine, I didn't have a calculator with me. 21. Yeah, you get degree mode. Yeah. You get 0.013. But I'm not, again, this is not my angle. I only take the sine or cosine of an angle and get a ratio or a decimal value. I have to take the sine inverse function to find the angle. So some people who seemed a little confused about that. That's a little bit trickier. That's a little harder than the XYR thing. Second one, cosecant is positive. So if cosecant is positive, what other function has to be positive? Cosecant is the reciprocal of which function? Sine. Okay. So sine must be positive. Which quadrants is sine positive in? Sine is positive in quadrants 1 and 2. All right. So let's do new page. Okay. And secant is also positive because we're given a value for secant. Secant is the reciprocal of cosine, and cosine is positive in quadrants 1 and 4. Aha. Here we go. I'm in quadrant 1. Hooray! Quadrant 1's easy. Quadrant 1 makes me happy. So my angle's somewhere here in quadrant 1. I just have to figure out what it is. Well, it says the secant is 2.5751. Okay? That means the cosine theta, take the reciprocal of this side, I got to take the reciprocal of this side, is 1 over 2.5751. I think this is where the confusion came in with this situation. Here I'm taking the cosine of an angle. I don't do the reciprocal of the angle, I do the reciprocal of the function. Again, I'm not doing the reciprocal of the angle here. I'm doing the reciprocal of the value of cosine, the reciprocal of the function, essentially. We never take the reciprocal of the angle. But it looks a little different because I now do the cosine inverse function on 1 over 2.5751. But again, this is not the angle. That's the value of cosine. And that'll give me theta, and it'll be in the first quadrant. So again, understanding the relationships between the angles and their inverses, pretty important. Not as important as the XYR thing. The XYR thing is huge. You've got to nail that one down solidly, because we'll use that one all year long. This we'll spend more time with over the year and master. Finally, the last one. Window washers have a contract to do the windows. The ladder is 26 feet long, 10 feet away. But a lot of people got the picture drawn correctly. 26, 10. And they even got to this side was 24. And then they said 30, 60, or 90 degrees. Is that a 30, 60, 90 triangle? It is not. In fact, I didn't even need to know this. All I need is this angle. So if that's my angle, theta, cosine of theta is 10 over 26. So I take the cosine inverse of 10 over 26 to get the angle, theta. That's all I had to do. That was all that needed to be done. I didn't even need to know that third side was 24. That wasn't important to what this question was asking. The other question would have been, that I could have asked here, is how high up is the ladder up the building? Then you'd have had the 24 feet. But that is not, a lot of people go with 30, 60, 90 triangle there, and that's not the case. So anyway, like I said, there were some oopses on this quiz. I mean, the good news is I do generally drop a low quiz each quarter. So if this was a low quiz for you, it could go away by the end of the quarter. Yay. All right. So that's good news. Tests, no, I don't drop tests. Test is tomorrow. This is about half your test. What else is on that test? Stuff from the first half of the chapter, just identifying the XYRs. Angular and linear velocity, yeah, there probably will be one of those types of problems on there with the unit cancellation. But don't spend your time focused on that. Raw percentage-wise, less than probably 5% of the quiz. Maybe even less than that. The points come from the Angular stuff. Focus on this stuff, the XYRs, the definitions of the functions, where it's sign positive, where it's cosine negative. It's really much more in the second half of the chapter. We spend a lot of time looking at that. And that's what we've got coming tomorrow. Now, being first hour, you guys have an advantage. If you do not think you can finish your test in the time that would be allotted during the class period, we got a full class period, but if you don't think you can finish, you may start early. But I prefer not to have people going over late unless you have a study hall next hour. But I have a class in here, so it does get kind of awkward. So if you think you're the kind of person that needs extra time on tests, my advice to you is be here at 7:15 and get started. I'll be very happy to give you the test early, if you like. Yes?
Can I get my first quiz back in study room?
I'd have to find them. I don't even know where I've got them stored right now. These are stats. That's all stats. I know I collected them back. The question is, if I can find it, yes, but if I can't, you can check with me later in the day to see if I